In this video, I'm going to discuss the solution of problem 27 of your homework number 2. The solar radiation of Salina, Kansas during the month of July is uniformly distributed from 6,000 watt hours per square meter to 8,000 watt hours per square meter. Once again, please note that the distribution is given to us for this question as well. It is a uniform distribution. Part A. What's the random variable x described above? Write the distribution of x using the standard notations. Clearly, the random variable x is the solar radiation of Salina, Kansas during July. So we can write down the definition of x as that the random variable x is equal to the solar radiation of Salina, Kansas during the month of July. That is the complete definition, but for simplicity I will just write it as x equals solar radiation. And then we also need to write the distribution of x using the standard notations. So the distribution of x can be written as x is distributed. For the uniform distribution, you can write uniform complete word, or you can write unif, or you can simply write a u. Let me write unif for the uniform distribution. And then I need to define the lower limit and the upper limit for the uniform distribution. Clearly, the lower limit is 6,000, comma, the upper limit is 8,000. Please note that if you have a random variable x which is uniformly distributed, say from A to B, the standard notation is we write it as x is distributed uniform A, comma, B, where A and B are given in the question. For this example, A equals 6,000 and B equals 8,000. If you need to draw the histogram for that distribution, it will be a rectangular distribution existing from A to B only. So if your A is somewhere here and B is somewhere here, it's going to be a rectangular distribution like that. What should be this vertical height? On the y-axis, that vertical height should be 1 over b minus a. Now for this question, a equals 6,000 and b equals 8,000. So if you draw the histogram for this specific distribution in the question, it's going to be from 6,000 to 8,000, a rectangular distribution. So what should be this vertical height right here? That vertical height should be 1 over 8,000 minus 6,000, which is 1 over 2,000. All right, let's keep those things in mind and go on to part B. What are the mean and the variance of the solar radiation that should be expected in Salina, Kansas during the month of July? That means basically I need to find the mean and the variance for this specific uniform distribution between 6,000 and 8,000. So for the uniform A to B distribution, how did we define the mean? Mean was defined as 1/2 times A plus B. Therefore, the mean for this specific distribution should be equal to 1/2 times 6,000 plus 8,000. So it's going to be 14,000 divided by 2, which is 7,000. All right. In addition to that, we should also find the variance. So how did we define the variance for the uniform A to B distribution? It was defined as 1 over 12 times B minus A, everything squared. So for this question, it should be 1 over 12 times 8,000 minus 6,000, everything squared. If you simplify that, you're going to get 333,333.3. That 3 is going to be repeating. All right, let's go on to part C. What's the probability that the radiation could be less than 7,200 watt hours per square meters? That means I need to find the probability that x is less than 7,200. So how do you find that? In order to find that, we're going to need the distribution. Of course, The calculator is not going to be helpful for this question because the uniform distribution is so very simple. Therefore, under distributions, you cannot find the uniform CDF. So we are going to draw the uniform distribution just like under part A we already drew it. The uniform distribution is a rectangular distribution and it's going to exist between 6,000 and 8,000, and we said the vertical height right here is equal to 1 over 2,000. We need the probability that x is less than 7,200. So 7,200 is somewhere here. We need x to be less than 7,200. Therefore, I'm going to go ahead and shade the area to the left from 7,200. So the probability value that I need is the shaded area. Well, of course, that shaded area is a rectangle. So the area of a rectangle is one side times the other side. So the height is 1 over 2,000. That times the length is 7,200 minus 6,000. So this becomes 1,200 divided by 2,000. If you simplify that, you get 0.6 as the answer for that question. Let's go to part D. What's the probability that the radiation could be within 6,800 and 7,200 watt-hours per square meter? The way the units are written is a typo. Please ignore that. Once again, this means I need the probability that x is going to be between 6,800 and 7,200. Once again, we are going to need the histogram for that uniform distribution. Again, it's a rectangular distribution from 6,000 to 8,000. This time I need to find the area between 6,800 and 7,200. So let me assume that 6,800 is somewhere here, 7,200 is somewhere here. So I need the area of this shaded rectangle. Rectangular areas are always easy to find. Those are going to be equal to one side times the other side. We know that the height right here is equal to 1 over 2,000. Therefore, the area of the rectangle should be 1 over 2,000 times 7,200 minus 6,800. Simply one side times the other side. 7,200 minus 6,800 is equal to 400. That divided by 2,000 is the answer that we need. So if you simplify that, you get 0.2 as the answer for that question. All right, let's go on to part E. Find a radiation reading so that only 10% of the radiations reported in the month of July will be greater than that. Now that question is an inverse calculation. This 10% is a probability value. Even for that question, we are going to need to draw the histogram. So here's the distribution. It's going to exist once again between 6,000 and 8,000. And we said this vertical height is 1 over 2,000. And we are given a 10% probability. So is that 10% on the left tail or on the right tail or somewhere in the middle? Well, in order to decide that, we need to read the question carefully. So that only 10% of the radiations reported in the month of July will be greater than that. That means this given 10% should be a right tail area. So that 10% is somewhere on the right tail like this. I need to find the x value right here. What we know is that this shaded area is equal to 10%, which means 0.1. All right, now we can easily write down an equation for the area of this rectangle right here. So how do you write an equation for that? One side times the other side. Of course, the height is equal to 1 over 2,000. The other side should be 8,000 minus x. That area should be equal to 0.1. Alright, now we can easily simplify this equation. We can multiply both sides by 2000, then we get 8000 minus x being equal to 200. From that, if you simplify for x, you get x equals, of course, 8000 minus 200, which is 7800. You may also keep the units for x. The units are watt hours per square meter. Alright, that's it for problem 27 of your homework number 2. Thank you.